Hello, everybody. So many Kotlin fans here. Just a quick show of hands, how many of you are not familiar with Kotlin and haven't tried it yet at all? That's a fair percentage. Say less than half of the audience, but still. Okay, we are going to talk about how to construct DSLs in Kotlin and what are the syntactic elements that allow doing it, natively in Kotlin. My name is Anton. I work at Jetbrains as a developer advocate for Teamcity, which is not really related to Kotlin, but it uses Kotlin for configurations. And it's a Kotlin DSL also. So this is why I'm talking about Kotlin DSL and how to construct it. DSLs are not the new thing. You probably have heard about DSLs before, or maybe you have even created one. And why would I talk about DSLs again? Because there's many talks about DSLs already. The thing is, it's changed, right? In the past, if users tried to use DSLs constructed by someone else, it was mostly painful, and only the authors knew how to use them, actually, due to fairly bad tool support or dynamic nature of those DSLs. With Kotlin, you can actually get all the nice features for the programming language, as it's statically typed. It's implemented to work well with tooling, and therefore it's much easier to use today. So if you talk about the main specific languages, they are tailored for the specific task, right? So if you think what kind of formats or languages you know that are tailored not for general purpose, but for some specific tasks, what comes to your mind? Sorry? XML. I would say it's a rather general purpose format, but SQL is probably a better use case, or XML for AND, right? You get the vocabulary of XML, like in XML format, a vocabulary to construct the builds, or Gradle, for instance, right? Or a language to specify graphs, dot, right? To draw the diagrams, or UML diagrams, or something like that. And if we talk about the theory a little bit, we can separate those into external and internal DSLs, right? For the external DSLs, you implement a grammar, you could implement a parser, you have to build tooling support, and there are some frameworks and workbenches to implement external DSLs. For instance, at JetBrains, we have MPS, where you kind of develop an external DSL tailored for the specific needs of yours, and you get kind of a full ability to generate tooling support for that as well. Or you can create one using parser tools like Antler. Basically, like you are creating a new language, right? Or internal DSLs, where actually it depends on the host language, like Scala, Kotlin, Groovy. And it's actually not fair to call them new languages, because it's the syntactic sugar of the host language, and it depends totally on the host language to provide the features, right? You cannot really implement the new feature of the language like that's something new, because you depend on the host language. But we are going to stay on the dark side today and use Kotlin to implement internal DSLs, and you will see that we are not really developing a new language, but we are using the language idiomatically. We are using new syntax sugar to create DSL-like syntaxes in our programs. Here I will have to show you some examples first. There will be like 6 or 7 of them, and I want you to look at them carefully and see the similarities. So this is an example of Kotlin X HTML library, which is used to generate HTML documents. As you can see, it's pretty readable. If you haven't seen it before, you can read it freely and understand what is going on there, right? It generates the HTML document. Another one is Anko. It's the library for Android developers to generate layouts, right? Even if you haven't seen it before, if you don't know Kotlin at all, you will actually recognize that there is a text field, another text field, and a button down there, right? So it's immediate and like obvious what this code does. Another one is Gradle, Kotlin DSL. You, as Java developers, you obviously know Gradle, and you know that you can write Kotlin in Gradle scripts now. Exposed. That's a small library to talk to the databases. It's also pretty clear what is going on here. It's like we describe a table, right? We open the transaction, we create the table, we insert some values into the table, and make a select and iterate over the results. And even if you don't know Kotlin, it still is understandable, still readable. Another one is just a hobby project of a friend of mine, Nicola Frankel, who is also here. He created a library to create view layout for Vaadin framework. If you're a web developer, if you probably know about Vaadin framework, then you can actually use some Kotlin sugar to define those layouts. Pretty similar to Anko example that we have seen before. Another one, a DSL to write configuration files for Kubernetes. It's also possible. Statically typed. Some effects, right? OK. So instead of writing YAML, which is not statically checked, you can actually use schema to validate YAML files. But, well, not all the tools are actually supporting it. But here, you will get compile time checks for whatever syntax you write here. Another one, a product that I'm working on at Jetbrains Teamcity, the continuous integration server, where you can define your configurations using Kotlin DSL as well. Also pretty readable. We define a repository right on the top, which repository should be monitored for the changes. And then we describe the logic of the build. Like we give it the name and the ID. We say that it should monitor that Git repository or whatever repository we defined. What kind of artifacts it should expose after the build, how to build it, what kind of triggers there should be, either a scheduled trigger every half an hour or on every commit, and the dependencies on some other builds. So it's pretty readable. Validated and compile time before the build actually starts, and therefore it's safe. Another example, which is the last one in my list, is the Couture Framework, which was released just last week, I think. And this example is pretty interesting. Is that you see some Couture specific things in here, but on the bottom you will already see an example that we have seen like previously, generating the HTML document, right? So we can see a mix of two DSLs in one file, but those are not different DSLs. It's still the same valid Kotlin code that we write here, and therefore we can mix as many DSLs as we want in the same place. And it's all Kotlin that allows that with its syntactic sugar, actually. OK, did you spot the similarity? Anyone? So what was similar about those? Lots of curly braces, nice. That's because it's Kotlin. Anything else? All right, let me reveal that. So you will see a structure in any of those, right? Whatever they do, they have a structure, a nesting. So we start with some first method, something like that creates the object graph or like the entry point, right? In this case, a foo, for instance, and then it opens a block, the curly braces, right? And then we have another nesting block in there. We start assigning some attributes. Some attributes can be assigned as blocks as well. And there is some syntactic sugar that is provided by Kotlin that we can make it a little bit more safer or readable. Obviously, we can create, refer to the existing classes from that structure. And it's all highlighted in the IDE. You get all the auto-completions, refactorings, and so on. When you're actually using it, it feels like, so nice and magic. So let me type a little bit for you, and we'll see how you can create this kind of structures and what kind of syntactic elements you can use to create your own nice DSLs. So I have an example of Java code here. Let me make it full screen, actually. You can all read and understand it, right? But it takes a little bit of mental effort to skim through the lines of code and really, parse out what every statement does. And that by the end, when you have read it, you actually understand that it has created a client with a company and a Twitter, and it's in a pretty idiomatic way you write code in Java. Obviously, you can do it better. But let's see what's inside. So, for instance, the client is just, a class with the fields, getters and setters, a builder with getters and setters, and so on. So, and we are going to take this Java code and start transforming it in small steps and see what kind of small features we can use from Kotlin to actually create a structure, a nesting structure that will look like a DSL. So let's copy that. And paste. And idea actually tells me that I can transform the code into Kotlin code, and let's do that and see what will change immediately. So first change, you will see that instead of the type, we have the val keyword. We don't have the new keyword, and we don't have semicolons. Well, that's a little feature that I didn't care about before I started programming Kotlin. When I had to go back to Java, it was actually the killer feature for me. Don't know about you, but you should try. Anyways, it didn't change in any way to create a structure, I mean the nesting here, right? So it only transformed those small elements. Now we actually will start doing a little bit of transformations with the code and see how it changes. The first steps that I'm going to do are not going to lead to those nesting structures immediately, but we will see what kind of elements are important for us. So let's run this piece of code at first. Spot the little cat there. OK, so it printed out a string and a reference to an object, right? What if we wanted to print real values? But let's make a constraint that those Java classes that I have here in the package, I cannot change them. So that, imagine if they came from a library. They're packaged in a jar. The source code is not under my control. I need to do something. Normally, you would create some kind of a string util class, pass in the client, print in the value or get the value for printing. In Kotlin, the idiomatic way is to create an extension function for the client class. Let me close this part of code, and we are going to add. No, we are going to change this code first. So instead of writing it like this, we would do it the Java way first. So to console string braces. No, semicolons. We don't need semicolons here. So and since the client class doesn't have the toConsole method yet, we are going to create one, and that is going to be the extension method. Right, and it should return string, of course. And we are going to write the code first in Java way and make it more Kotlin-like. So return. Since it's an extension method, whatever is inside the extension method refers to the client, right? So if we type this, this actually returns not to the main or DSL class where we are at, but to the client itself. So this, and we are going to have the access to the first name, to the last name, Twitter, and so on. So let's say we are going to print a Twitter and a handle and space. We don't need this anymore. We can refer to the company field, for instance, company, a name, and just have it like this. What we can do here as well is to use templates, string interpolation templates, instead of concatenation. IDEA will actually help us with that, convert concatenation into template. And we don't really need to write the code with curly braces here, since it's just one-liner, and use the return keyword. Instead, we can just use the equals mark the same way as you have probably, if you have programmed in Scala, it's pretty similar here. So now it actually prints something, I think. And it works, right? OK. So just remember this thing. You can create extension functions, right? Now we can actually make it a little bit simpler even by using it as a property. So there are extension properties as well. Client, console string get. What was, OK, and copy this guy in here. Oops. And it should be val, of course. So instead, we are making this client code a little bit simpler. So those are like small elements that are building blocks for our upcoming DSL, actually. Now, we want to start transforming our code into the nesting structure. Now, how would we do that in Java? Normally is to have some kind of a method, like create something, create factory, create client, create person, and so on, and pass in some kind of a lambda, right? That will be executed inside the method call. If we think in Java, then to do that, we need to pass in an interface, right? A functional interface with one method. So fun, create client equals, it will return a client. And what kind of interface we could use? For instance, we could use consumer from Java 8. And it should be parameterized. In our case, the client is built using the client builder. So we are going to use that to parameterize our consumer. Do you know about consumer in Java 8? What it does and what is it used for? Right? It's a operation that takes in a parameter and returns nothing. So it basically has to do some initialization inside. Good. So what we are going to do here is to create a client builder, pass into the consumer, and basically get the result out of it, right? So val builder, client builder, C accept builder, and what we need to do is to return the result. Return builder build. Done, right? Now we can use this method to actually create our first nesting in our program. And instead of using it like this, we are going to just call the create client. And we need to pass in the implementation of the consumer in here, right? So object, it will be the anonymous implementation of anonymous class object. Consumer, client builder, and we need to implement the method. And the code that actually is going to do the initialization of the structure is already written right here. So we can just, copy and paste it right there. We just need to rename this parameter to make it compile. Builder, done. So we have nesting already. It looks ugly because it's not idiomatic in Kotlin. We implemented it Java-like way. And IDEA actually tells us that you can convert it to Lambda. So let's convert it to Lambda instead. because Kotlin natively supports lambdas. And now it actually tells us that I don't need to parameterize it on this call side. Of course, I can remove that as well. Oh, cool. Now it looks cleaner, but we still are using the consumer, right? What if we convert it to be more Kotlin-like? We have lambdas. Why would we need this extra interface right here? So let's remove the interface and actually specify the lambda natively in Kotlin so that it would, take a parameter and return nothing. Unit. Done. So, and we don't need to use the interface anymore, so we can just call that lambda directly. And we remove the interface. So now it's just the only parameter, which is also the last parameter in the parameter list. So we can move it out from the braces. Done. And it already looks like a small structure, right? We have the first verb, or like an entry point, and then we have a block right here, right? Now we have a block or a lambda with just one parameter, which is, there is a name for it. Everybody knows it, right? It. So it's it. We can just rename it at first. And since it's the only one, it's implicit, we can just remove it, right? Cool stuff. What is ugly about it? The ugly thing about it is that I have to refer to it every time. And it, if we turn on the hints in the IDE, it tells me that it is a client builder. So I have to refer to it. What if I would like to have the block, whatever I execute in this block, to be executed within the context of the client builder already, so without having to refer to it? Remember about this extension functions, right? We can actually say that it's an extension lambda, or the official name is lambda with the receiver. So whatever the block I pass in here will be executed in context of the client builder, and therefore I can get rid of it because I already have this, which is a client builder, and I will have a direct reference to the first name, last name, Twitter, and company, which are internal to the client builder. So I can just remove that. Ooh. Cool. And it looks much clearer. And my transformation is, obvious what I will do next. Obvious is that I will want to create a structure like this, Twitter, and initialize the handler inside. How would I do that? I don't have a method that is called Twitter in my client builder. And I have to call it within the context of the client builder, meaning that I need a new extension method, which is going to be called Twitter. Fun. Client builder. Twitter. And we need to do the same trick as we did previously to pass in a block which will be executed now in the context of Twitter builder, right? Twitter builder. And it should be a lambda that returns nothing. Good. So within this block, all I need to do, as you see, the client code already compiles in the top, like this. So as you can see, it already compiles, and we just need to initialize the field within the client builder by using Twitter builder, right? So let's assign to the Twitter builder. We need to actually call the block now by using the apply method. We can pass in the block and basically execute it within the context of Twitter builder. And now we have the structure that we can just assign to the field, and we are pretty much done. Nice. Let's see if it still compiles and produces the result. And look at the cat as well. So it's still the same, validated. And we can do the same for the company. Why not? So remove this call, move those 2 lines, remove this guy, and remove this. Done. But we don't have the company method yet, so we are going to do the same for the company. So it should be the company extension method. It will use the company builder, and do the same trick here. Company builder, and assign to the company field. Done. Nice. We have moved from the code that looked like simple Java code, that you all could read and understand, of course, to a structural code which has nesting, which is, well, you wouldn't say that it's much shorter in this small example, but when you have the structure, it's much easier to, parse with the eyes and immediately understand what we are creating here, right? Instead of skimming through the pile of text and actually parsing it and understanding what will be the result. Nice, isn't it? But there's a little problem with this code. Who can tell? Or maybe you have questions, actually? Anyone? Not yet. Everything is understandable. Everything is clear. Ray, you definitely have questions. No? No, OK. So the problem here is that imagine if a Twitter builder had a field called company. And we, by accident, we moved in the block in here. And somehow we did something wrong. The designer of the DSL did not intend us to use the company block within the Twitter block. But currently, this code compiles and it is correct by accident, right? Instead of letting the users to figure out the way how to create those blocks, I would probably like to build some gating or prevent them from nesting the blocks inside which are not designed for nesting. So I want to control the scope of those blocks. In Kotlin 1.3 or 1.2 actually, 1.2, there is introduced a new meta annotation that you can use for controlling the scope of those blocks, which is called a Dsl Marker. And that's a meta annotation. You cannot use it directly. You have to create your own annotation class, say client DSL, and mark it with that meta annotation yourself, say DSL Marker. And then you can annotate your classes that you use in that DSL with this meta annotation, and it will enforce the compiler check on those blocks for the receivers that are used in this structure. The problem here for us is that we cannot change those Java classes that we are using, right? They are in the library. We cannot annotate them directly, but we can derive from them. So we can derive and we can create our own, let's say, class, client builder, DSL, which is a client builder, and use our client annotation on top of that, like this. Right? So instead of the original classes, I would use the derived classes, and then the compiler will be able to check if those blocks are interleaving or not. And so instead of typing the code, I will just actually comment it out. And imagine I moved this code into the library so that it would be reusable for the others. There is no point writing DSL just for one case, right? There is a point if you create a DSL for reuse. Otherwise, you just introduce complexity, and there is no direct benefit of using this kind of things. OK, so I just move it into a different file, and I have created those annotations here, right, or those derived classes, company builder DSL, Twitter builder DSL, client builder DSL, and so on. And I have replaced all the calls to use the DSL classes instead. So when I go back to our structure here, we can notice some changes already. The DSL methods are highlighted. There's like, I can use that annotation to mark my DSL method as well. And IDEA will actually use that as a hint for coloring and for auto-completion as well. I will show you how it works in a second. But the greatest benefit of it is that if I start nesting those blocks within each other, the compiler will immediately highlight the error. I cannot nest them anymore. Highlighting works this way. If we annotate the method with our new annotation, the IDE will actually figure out what kind of color it should be using by the name. So just computes the hash, creates a color, and then when you start using it and start calling autocompletes within this block, the DSL methods will be actually placed on the top of the completion list. Because you're already using the DSL, and probably you want to see those DSL methods on the top. Nice, isn't it? OK. What if we want to do a little bit more with this client? For instance, a client is a person, and person has a birth date, right? Date of birth, actually. Date of birth. And normally, how would you assign a date in Java? What kind of library you use? Java time, right? So local date of whatever, let's say the 1st of March, and then 2001, whatever. Not really DSL-like, isn't it? What if I wanted to write it a little bit, natively, and I would read like the 1st of March of 2001. So let's see how can I do that. I actually have it already implemented, so I will just use the example and explain it further how it works. 1st of March 2001. So here I'm using something that is called extension method, which is infix extension method for the integer type. It's not really a good practice to pollute the global space with the extension method, but just for the sake of the example here, we can limit the scope how we extend the global scope anyway with the imports. The implementation is pretty obvious. I have an extension method, which is normal extension method as we have used it before. And since we only have one parameter, we can prefix it with infix keyword, and then we don't need to write a dot and the braces, and it then reads kind of natively and nicely. So there is no DSL for this kind of things yet. So if you wanted to create your own DSL, you can probably create a Kotlin DSL for Java date. Why not? OK. So what we are here at? OK. Let me show you more. It's like this example is basically like a hello world example, right? What if I show you some real example with Teamcity? So this is the real DSL, and if you see this kind of call here, like a name of some term followed by the block, you can immediately tell that there is a lambda with the receiver, right? So if you navigate into the definition, you will see there's lambda with the receiver. If we follow along to the other structures, like a project, then we have like a library, which is like a build configuration. We can see some more blocks in here, like what kind of VCS route we should monitor. And if we go there, we also see Lambda with the receiver. If we go further to the steps, we also see Lambda with the receiver, and so on. So this is like the ultimate block for building this kind of DSLs enabled by other features of the language. Let's go back to the previous example. This kind of structure is not fully safe as well. Imagine if you are designing a DSL, you have created this kind of structure, but you did not enforce the user to field some kind of ID, right? The ID is obligatory, right? So you have to, and there is no means for actually controlling what kind of field is obligatory. The only way is to actually create the signature of this create client class to accept more arguments so that the user could not skip defining it, and still you would not be able to enforce the format of the ID. So for instance, string, I mean, we could fill in, like, give it an empty value, for instance, right? It would not be correct. So I hope, I haven't tried it yet, but I hope contracts, that is the experimental feature in Kotlin 1.3, would enable that, so that you have to put in the ID that is, you know, of a certain format, or, you know, to be able to define how many times a block could be defined within the nesting block, and so on. But here, in this simple example, I would be able to give it like a parameter. Like, I would at least notify the user that, hey, you have to specify the ID, and he will not miss it. And by using name parameters, it's pretty nice to, you know, specify it with this kind of syntax as well. If you have used Kotlin already, you recognize it. Okay, this is my kind of final thing in my demo, and I will go back to the slides. And actually, there is not much left. So if you were new to Kotlin right now and you didn't know anything, you just have to remember there is like Lambda with the receiver, which is the most advanced thing for building the DSLs, and the rest is just, you know, complementary to make it look nicer. If you want to start learning Kotlin more, there are books about it, there are courses that you can apply to, and use IntelliJ plugin to, you know, make the assignments and so on. So if you have any questions right now to me, come and ask, and I'm happy to answer. Anyone? Anyone? Okay. Thank you.